Hi guys, so we have a logarithm problem. So this was a number 7. So we have a square root of some expression, and what we want is this result is a real number. So based on that, so what would be the number of integer and satisfy this square root of the expression we are given? Okay. So first things problem I will remind, whenever you have a log. Okay, so regardless of any base, let's say this is a, b to the x power. So, a is our base and then b to the x is our argument. So you can take this power of the argument and place it in front as a product. So you could be written as x times the log base with a of b. So you can do this backwards, so which is okay. Sometimes we are going to need that as well. And then that's called a power rule or power property. So let's use it. Everything right here, this is log n and then log n, but this is log n to the second power. So which is why I will pull this 2 in front. So that could be written like 2 times the log n minus, we have log n. The square is the square of the whatever number we are going to get from that log n. And this divided by, okay, to log n minus 3. So just keep in mind, we are trying to make this a real valid expression. Only way that will happen if the whole thing inside of the square root has to be non-negative, right? So that is what we want to satisfy. And since all the terms has log n, so maybe you may either pull as a factor or you can do substitution if you like to. So I can like write log n maybe equals like x. Okay, if you do so, you will get like 2x minus x squared over x minus 3, because that is usually what we see a lot. So that's why I kind of do this substitution. Okay, and also we can just factor the numerator, which will give us like x times 2 minus x and divided by x minus 3. So you don't have to do this, especially if you can kind of do this with the log n, which I would do, to be honest, if I was doing this problem. So, but it's okay to do it. So now we have a rational function inside a square root. So whenever we deal with that, so I would love to have the sign diagram of the zeros of the numerator and denominator. So you can get 0 like at 2 and 0 and 3. So the smallest one is 0, the other one is 2, and the next one is 3. These are the zeros of the numerator and denominator. So if you choose anything, smaller than 0, this is going to be negative, and then 2 minus a number that is lesser than 0 will be positive. This is going to be negative. So if you divide 2 negatives, you'll get a positive. So this will be positive. So this will be negative, this will be positive, and this will be negative. So again, we do have these as kind of sign change immediately because there is no like the even multiplicity. So the sign will change. You can always plug some value to test that, but that would be the case. Um, as soon as we have that, we just like to see when this is going to be positive. It's going to be positive if x is smaller than 0 or in between 2 to 3, right? So like then, but be careful, x is these guys, but we were given log n is going to be smaller than 0, okay, because that's my x, and the log n is going to be smaller than 3, but larger than 2. So if you keep in mind that 3 cannot be the value, which means you cannot have this 3, but you can have actually 2, so which is why it's possible. If you take this is like base 10, right? So if you take the base 10 of this, so that will be 10 squared, which would be 100, smaller than n. That will be smaller than 10 to the third power, which is 1000. So this is not possible because that will make denominator 0. So that means anything between 100 to 999 would be okay. So you can just think about 1 through 999. So 1, like 2, 3, all the way to the, let's say 99, 100, all the way to the 999. If you have this whole list, that means there are 999 numbers. Okay, but we are missing the first, we are taking the 99 of those numbers out of the counting, which is gonna give me 901. including 100. So which would be my answer, choice C. So again, there is a choice like 900 or 902, which is why we have to be extra careful. So in this case, like some people may go with the 902 because 3 it has to be careful. So which make denominator 0. So if you miss that, you can go with 902, which is not the correct answer anyway. So I hope that makes sense. This is just asking us to remember some properties of log, which is only one property, plus how to deal with the rational function when you have some zeros. Okay. So I'll see you in the next video.